Okay, so in the last session, we seen a parameter of instrumentation flow, and in this series we are discussing the interview questions. What a engineer should know. If you're not interview also, but if you are an engineer, you should know these small things. Whatever may be your trade, it may be mechanical, electrical, electronics, or instrumentation. Everywhere, these questions are applicable. These basic principles are applicable. So before I start, I will ask from you, some of you will give me what you know about the pressure. Can you tell me what is the definition of pressure?
It is the force exerted on a unit area.
Force on unit area. Right? So what is the SI unit of pressure? Yeah, Pascal is the SI unit. Right, that's right. Okay. Now you can give 2-3 in a journal example of pressure which you see, or you can apply this formula on the pressure. Journal example means the examples from your kitchen, example from your office, example from when you are going to the roads, to the college or the home or the party and all. Can you give some examples? Yes. Pressure inside the tires. Okay, one example. Okay, from kitchen? Pressure cooker. Very good. Pressure cooker is a very good example to understand, and it will not tell you only the pressure, it will also tell you the process. So can you tell me, what is this example? The example of the pressure inside the pressure cooker. Can you tell me, what is this example?
Pressure limit से बाहर एक्सीलर तो
Yeah, if pressure is more than your, what is it? Whistle, safety whistle, then it lift and excess pressure gone.
yes.
Yeah, that's a kind of control. And your pressure cooker is not displaying any pressure, but it is controlling the pressure which is predefined by the whistle. And there's one more thing is safety valve. If it is more than that, something clogged inside, the safety valve pop and your steam gone. But the understanding of the process is different. Now, in the same pressure question, I will put in a different manner. If you have a dal means, what is the English of dal? Lentils. So, when you cook it in an open bhagona or vessel and the cooker, right, it will take 25-30 minutes. But when you cook in a pressure cooker, it cooked in a 5-10 minutes. Why? What happened there?
Pressure area.
Area. Okay. Why you are smiling too much if you say area? See, this is the basics. These are the basics because this we are seeing from the childhood. But what is the behind it? The principle, the laws, the natural laws, that we don't know, and that is required. In an interview, people will not ask the very hi-fi things. They will ask very small things which you are seeing day in, day out from the childhood. You ever thought about this? If it is an open pot, it will take a more time to cook, and with a pressure cooker, it will take a less time to cook. What is happening in a cooker? You put the food, put the water, close, start, then what will happen? Yes, at 100 degree water will boil and steam generated. And when it is a closed vessel, steam will not go anywhere. So what will it create? More pressure. And now the basic law which 9, 10, 11, 12 you have been studying, and in engineering you have to apply actually. So what is happening? The boiling point of water increases. So now it is not like an open pot, it is not cooked at 100 degree, it may be more than 110, 120 degrees Celsius. So due to closed vessel, the pressure increase, boiling point increase, and that's why it is cooking fast because temperature is now more. Got it? So some more example I am giving you. You have in a kitchen only, you have one sharp knife and one blunt knife. Which will cut fruits faster? Why? Because its area is sharp, na? You have a nail. You have to put a nail. Don't put here, na? On the wall. Why? Because area is sharp. So from where it's coming? P is equal to F by A. Area is less. Now you have a bag. Backpack. So you see in a backpack, this thing steps are broader. P is equal to F by A. They are increasing area so that pressure will decrease. So always it is flatten. Tractor. Have you seen tractor tire? How is that? Too thick, na? Why? Because they are supposed to go to the field for the farming purpose, and their soil is loose with the water and all, so it will not sink. So they are increasing the area. P is equal to जोर से P is equal to, so they are increasing the area so that it will not sink. Got it? So this is now definition of P is clear. Per unit area, what is SI unit? And then in the case of the pressure, there are so many units, different units. So we will try to understand those units also. And this section, we will understand many other things. Like we will first see here how it looks. You already seen in our office, in our training center, we have some pressure transmitters. Right? So this we have in our office. This is a ceramic type PT. PT means P pressure, T transmitter. PT. It is a 2-wire pressure transmitter. Why? Because we are giving here 24 volt and DC, and we are giving, and it is giving to over that 420 milliamps. And here after this class you will have the hands-on on this. You understand what is the 24 volt, how the connection is done, and how 420 is coming back. Why I am saying it's a 2-wire transmitter, right? We also have this pressure gauge in our office. Both are for the measurement of the pressure in the process, right? So here you also see, here there is no electrical transmission. Only you can see at the point of where you are measuring the pressure. So few things are very important. You will also take in your hand, and I will show you that practical also. So this is the gauge. What is the range?
0 to 10 bar.
Huh?
0 to 10 bar.
0 to 10 bar. 0 to 10 bar. And here it is written CL. Here it is written CL. Are you able to see it? CL? No? Okay. When you will take in a hand, then you see here it is written CL. Then you will also understand the pressure or any other device also. What is the meaning of these divisions? If I ask, what is the least count of this gauge? What is your answer?
0.2.
How? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 division, and this is 0 to 2 divided by 10. It is a 0.2 bar. Got it? Then this is what? This is process connection. Here also this is the process connection. We will tell you in detail what is the NTP, what is the BSW, and what is the half inch, quarter, 1.5 inch. This is the process connection when you put inside the pipe. Okay. This is again pressure gauge. Now we will go further on the pressure. So before going to the pressure transmitter or temperature transmitter, we try to understand what is the meaning of sensor and what is meaning of transducer. That's a very pet question of interviews. Can you give me answer? What is sensor?
Physical.
Sensor means it is just sensing. It is sensing some particular parameters like flow, pressure, temperature, level. Is used for only sensing. And what is transducer?
Converts into electrical energy.
Tell me. What is transducer? What is that transducer? You can say not a physical energy. That's the wrong. Not a physical energy. That's work of sensor. What transfer doing? It is changing one form of energy to other form of energy. This is a definition given by the mechanical engineers. But you are electrical engineer or you are instrumentation engineer, ENTC engineer, then you can give a definition a slight different. So what you say? Any form of energy to electrical energy. Because you are concerned when you get a signal in an electrical form to your electronics, then you will do something. Now I am giving you some more points on that. Read it loudly.
A sensor is a device that has a characteristics that changes in a predictable way when exposed to the stimulus it was designed to detect.
So sensor work is only to detect, only to sense. What is transducer, Atharv?
Transducer is a device that converts one form of energy into another.
That is a broad definition of a transducer. Correct. Okay. Now you see here. The instrument, they may have a sensor and transducer inbuilt also, and sometimes sensor will be different and the transducer will be different. Like case of pH transmitters. They have an electrode and they have electronics. They have a sensor, then they have electronics. Sometime in the pH only, if the pH sensor is directly now smart and advanced pH sensors, they have a sensor part and electronic side inbuilt, and directly RS-485 or Ethernet protocol, the communication they are providing. So that time they are both are the one. Nowadays, sometimes all are same. Sensor, transducer, controller, these all are smart transmitters. They can have all three function in it. But you should identify. Sensor means detection. Transducer means to change in a electronics. Controller means to take any control action, and all should be predictable.
So display हमारे सेंसर हो सकते हैं मतलब
Smart sensors can be, but if you talk about the conventional, then everything is different. Sensor different, transducer different, and your display different. One more word comes as signal conditioning. So normally the transducer they do that signal conditioning only, because it is dependent on the requirement. You want a heart output, you want a 420 output, you want the Ethernet output, you need a pulse output. Got it? So now here you can see, sometimes your sensor is different, but your transducer and controller are same. And if it is a controller, it can be a display also. Correct? Got it? Till now? Fine. Now we will go further. After understanding the sensor, transducer and the controller, we should know with that my pressure transmitter or temperature transmitter or the flow transmitter, the level transmitter or any other parameters transmitter, what kind of output they give. Tell me, you are here, you also worked on a different instruments. So what kind of output they give? 420 was then
0 to 5
yes, 0 to 5, 0 to 10, very good.
sometimes a digital signal 0 and 1 or 0.
Digital signal, you can say status also. Okay, very good. Then what digital signals you used? Where you put the ID, baud rate, parity, what was the signal? Now before we go, this is a very important question. People will ask you, what kind of output a transmitter can give? So in your mind is a picture. We can say the transmitters or the instruments can give two types of output. One are the analog, one is analog, other is digital. In the analog, 420 milliamps or the voltage. In the digital, there are many. It starts from the Modbus. In the Modbus, RS485, RS422. Then Ethernet. Then your HART. Then your Profibus. And there are many proprietary also. Like in a HAVC application, all they use nowadays, BACnet. Okay. Now, Athar, you come and you explain in this transmitter what are the outputs.
So we have this transmitter.
Show there, your mouse should be there. हाँ हाँ नहीं नहीं उनको दिखाओ. Come back. हाँ चलो.
So we have this transmitter and it gives us Modbus output, then pulse output and current output.
It can give 3 outputs. Now we see another thing which is giving you Ethernet output, and it can convert RS485 to Ethernet. You can see also.
So this is a MUX converter. It gives us Ethernet output from port RS232.
It can be used with the devices which are providing you RS485 or RS422 outputs. So this is the converter which is converting your transmitters RS485 or up you can go 420 output to the Ethernet output. The companies like Honeywell and all, they are working in a building management system. So normally in the building, in the office, in your college and all, they have a Ethernet network. So this signal go to the network, and from network it will go to the BMS. And the BMS, there is a screen. On the screen they will see the output of these instruments. Okay. Now we will see here. So these are the mainly pneumatic, current and the voltage. Pneumatic is used where? Your control valves. What was the pneumatic signal? 3 to PSI. Right. So now you see what you discussed. This is the pressure. So pressure is defined as the force divided by area exerts on solid, gas or liquids. P is equal to F by A. What are the dimensions? PA, Pascal, PSI, then bar, PA, atmosphere and the torr. And there are many more, kg per centimeter square. Is it or not? So this is a quiz. Convert to ATM to PSI. Given 1 PSI is equal to 6897 PA. So this is just an example. This kind of questions people may ask in your interview. Like 1 kg per centimeter square is equal to how much PSI? This is a very common. Then from the point of view of the control valves, they will ask control valve, what is pneumatic pressure? 3 to 15 PSI. Can you convert in a kg per centimeter square? So it's a 0.2 to 1 kg per centimeter square. So this should be on your tips to conversion. 1 ATM is equal to how much PA? 1 ATM is equal to how much kg per centimeter square? If you don't know, write down in one page and review many times so that you will remember that. Okay. Pressure is 2 types. One pressure is the static pressure, other pressure is the dynamic pressure. So in the static pressure example, there is a column which is having the water. Whatever the height of the water is equivalent to that pressure. That example we discussed when we are discussing the properties of fluids. So I told you that time head, HEAD, head. So I told you one thing that time, and that was the question: if I have 1 kg per centimeter square pressure, then what should be its head? Remember or forget? What is that? It is 10 meters. So this is the static pressure. Dynamic pressure means you have a pump or something is pushing. So that pressure is the dynamic pressure. Now for the example of the static pressure is your pani ki tanki. And from the pani ki tanki it is a heighted. So water is coming from here, coming to your house, and second story or third story tank without any pumping and all, it can fill. So it has so much of pressure so that it will go to your second story or third story of your house, the head. This is a very good slide. Now you see here, there are three kind of pressures. One pressure is your, I can say P absolute, I can say P gauge, and I can say P vacuum. Okay. So we have to understand what is the meaning of what. Here is the vacuum. After that. So if you see, this is the atmospheric and this is the gauge. Total of both is the absolute. Got it? Absolute pressure equal to P atmospheric and plus Pg. If I am talking to Pg means P absolute minus P ATM. Got it? And vacuum pressure is the here zero. Here pressure is the zero. Below zero is the vacuum. It comes in a minus. What it means? Suction. Vacuum pressure means suction. If pump is pumping the water, so there are two sides. One is the suction side, from water is coming, and delivery side, water is going. In the suction, there is a vacuum. Then you say the example of turbine. Turbine, you are giving steam, na? And due to steam, it is moving. So where the steam is going? After work done, somewhere in the water, it is on deaerator. So in the deaerator, there is a vacuum. Then only that steam will go to the deaerators. Okay. Then in a power plant example, we can say condenser extraction pump, CEP. So in a condenser, it is taking water and giving to the hot well, or sometimes direct to BFD, boiler feed pumps. So again, there is a suction. Whenever you are taking something from some sump or somewhere, it has to be suction, and that suction is the negative pressure. Got it? Clear? So three pressure. Now one fourth pressure may also you know, because you already understand the flow meters. In the flow meters, when we are studying orifice plate. So in the orifice plate, how I made it? This is the orifice plate symbol, and here is the P1, here is the P2. Okay, it is like this, na?
Yes.
So here's the so 1, 2, 3, and the 4. Write down. Already written. So this is very important for the point of view of the interview. What is the definition of pressure? Any simple examples of your normal day-to-day work, and pressure cooker. From pressure cooker, the question how your food cook faster in the cooker. Got it? And then pressure two types: head, static, and the dynamic. And then very important question was head. So you understand the head. 1 kg per centimeter square is equal to 10 meters of the head. 2.5 kg per centimeter square pressure is equal to 25 meters of the head. Then these lines, 1 line, 2 line, 3 line. The bottom line is 0. And this is the total. So absolute is equal to, because everywhere everyone is facing the pressure, that is the atmospheric pressure. Got it? And then your process have a pressure, like compressor has a pressure. So in the gauge it will show 5, but if a PA, then gauge pressure is whatever is the atmospheric pressure that time, that you have to add in that. And any pressure below 0 is vacuum. Differential pressure, difference of pressure. Clear? So this is the recap. Now how we will measure the pressure, that is point will come. Exercise: find the absolute pressure. Your ears should be open. Find the absolute pressure if a pressure gauge reads 8.3 psi while the ATM pressure is 14.7 psi. Give me the answer, fraction. Okay,
23.
good. So here one more catch. This 14.7 psi means 1 kg per centimeter square is equal to 14.7 psi. Right? Good. Now you see here, this is the static pressure. If the height of this tank is more, you have a more pressure, because formula is P is equal to rho GH. In case of water, rho is 1. So if it is a big tank and someone will ask what is the pressure, then whatever the height of the water column multiply by the gravity multiply by the density. For the case of water, density is 1. So you can say this is a how much of kg per centimeter square, and by that figure you can also identify. Exercise. A pool has a water with a depth of 6 feet. Find the pressure at the bottom of the pool in PA and PSI. Assume density 10 to the power 3 kg per m cube. So this kind of question of the conversion people may ask you. So you have to be very clear on the conversion. It is not applicable to pressure, temperature, flow, level. For everything you should know the dimension at least, because experienced industrial people know at least you should know the dimensions and the conversion of the dimension. If you don't know, then you revise it. Write down the paper, do revision so that you will remember. Now we have seen what is the pressure. In this section we will understand how we measure the pressure. So if I want to measure the pressure, then I have to first divide what kind of pressure, because if you go to the hydraulics, the pressures are too much. You talk about the small flow measurement or the medical science, the pressure and all, then it's too small. So we have to categorize my instruments in a 3 categories. One category is moderate pressure, which is general we use in a industry and all. Second is the very high pressure, and then we on the very low pressure, blood pressure or many other pressure in the medical science, they are very less. So the transducers, the sensors will be different for different. Normally we will talk about the moderate and the high pressure. Very low pressure we are not going to study, but you know, a small idea, because if company comes from the medical instrumentation, so that time they may ask the question. That's why I've kept a small things for the pressure measurement on the medical instrumentation side or medical science. So for the moderate pressure, very common thing which we used when I was very young engineer, because that time we don't have a very good instrumentation. So that was the manometer. You know manometer, how it looks? Manometer. Write down your copy. Manometer. If you talk about the pressure, you must know what is the meaning of manometer. Then elastic elements. There may be diaphragms, bellows, capsules, burden tubes, spiral or helix construction. This is a construction of your sensors. Okay. High pressure, there are many electrical, then wheat stone bridge, remember? Hello. So that kind of thing, ceramic type of thing, diaphragm type of things, we can use a high pressure. For the low pressure, you can write in your copy, this is a McLeod gauge, Pirani gauge, ionization gauge. I'm not going in the detail of these gauges, but you should know at least the name of the gauges, and you have a small study on this, how it works and all. Though it's very less in a use, but as an engineer, you must know for a very low pressure measurement, we use these 3 kinds of gauges. McLeod, Pirani and the ionization. Okay, read loudly.
Pressure transducers. Pressure sensor either convert the pressure into mechanical movement or into electrical output. Complete gauges not only sense the pressure but indicate them on a dial or scale.
Yes. So now what we are talking about? We are talking about pressure gauge and we are talking about pressure transmitter. In the gauge, what is happening? That mechanical movement will come on the dial and you show in a needle how much is the pressure. In the electronic one, you have to get the electrical signal. So now what we are talking about? We are talking about this. Pressure sensors either convert the pressure into mechanical movement or an electrical output. Complete gauge not only sense the pressure but indicate them on a dial or scale. Mechanical movements is produced with the following element. It may be burden tube, it may be a spring piston, it may be bellows, it may be capsule, it may be a diaphragm. Now you analyze first words. Convert the pressure into mechanical movement. If you see this, this is the pressure gauge. Okay. Inside that, what is there inside? Burden tube. What burden tube do? When I give a pressure, this is a pressure pump. Hello. This is a pressure pump. It is used for the calibration of any pressure transmitter or gauge. What we do here, we put a standard pressure transmitter, and here we put the whatever the gauge in a test. This is the master, this is a test, and by this pump we can build a pressure, and from these knobs the coarse is a fine. We give like 4 kg centimeter in the master. That should be the same here. If it is not there, by their accuracy we can check, we can use this gauge further or not. If it is a transmitter, then we can do the span and the zero adjustment also. In fact, in a many pressure gauges mechanical, we have a that adjustment, zero adjustment. Okay. Now you go to the second line. That line shows into a electrical output. This you are seeing, this is a pressure transmitter. That was gauge, and this is this is a gauge mechanical. This is electronic instrumentation. Okay. Now what is saying? The mechanical movement. Now sensor part. Sensor is not physical, sensing the physical quantity. Here is the pressure. So these are the things which will sense. After sense, either they give the electrical output or the mechanical movement. Like in the case of the gauges, they are giving the mechanical, that burden tube is flattened, and with their pointer and gear assembly, it is showing is the calibrated dial, what is the reading. Okay, and this is the transmitter. This is a diaphragm. Inside it is diaphragm. You are not able to see. These all things inside the instrument. Here you are not seeing burden tube. Here you are not seeing diaphragm also. They are inside that. Now I will show you how physically inside these looks like. See, pressure gauge. Pressure gauge. Inside this pressure gauge, this is the process correction. This, you seeing this brass? This is a process correction. So we are just tightening it in the pressure pump. Then inside that, this is the burden tube. Inside it, this is the burden tube. So pressure come here, go there. Due to this, it increase the length. When increase the length, then this pointer moves and the gear. So it will change the direction and the scale. So people will ask the question, how a pressure gauge works? What is there inside the pressure gauge? What is the burden tube? How a pressure gauge works? These are 4 or 5 questions based on this. This picture you are seeing, you are seeing this picture. Physical. What is inside it? This is the inside it. Okay. So it's a sensor. And burden tube is doing the mechanical movement. Clear everyone? Okay. We will go further. Now we'll see the burden tube. Yeah, you read it. Read it. Louder.
The border tube is a hollow tube with an elliptical cross section. When a pressure difference exists between the inside and outside, the tube tends to straighten out and move. The movement is usually coupled to a needle on a die to make a complete gauge. It can also be connected to a secondary device such as an air nozzle to control air pressure or to suitable transducer to convert it into electrical signal.
This type can be used for measuring pressure difference.
So both is help. Delta P also and here also. But we are not talking about the only pressure sensor. But you should know because you know all four types of the pressures. Can you tell me what are the four types of pressures? All can tell me.
Absolute pressure,
Differential pressure.
atmospheric, gauge pressure, vacuum pressure.
Okay. So you should know every time. This is a very pet questions in our interviews. Piston type. That was a burden tube. This is a piston. Again, same thing. Pressure is coming, and with the piston and spring, it is moving. And that movement with the gear assembly and all, with the pointer and the calibrated scale, you can see the reading of the pressure. This PPT will be yours, so you can do more study also on that, and you can come back if you have any doubt. Because today is a rapid round. We are not going the details of that. Only preparing for the interview. Then diaphragm movement. That diaphragm movement is changed to the electrical. That is the bellows means like this, lot of this bellows. Got it? Then strain gauge, piezoelectric, and some other things. People can ask, can you give me some examples of pressure transmitters, principles, how they work? You can say diaphragm, strain gauge, piezoelectric. What is the active transducer? What is the passive transducer?
ट्रांसफर मतलब आउटपुट इलेक्ट्रिकल एनर्जी से देता है, डिपेंड रहता है इलेक्ट्रिकल एनर्जी पैसे
Mahagalat. Write down passive transducer, active. First sensor, transducer, then the transducer. Two types, active and passive. Now you tell me, in your photovoltaic cell PV, do you need any external energy? No, na. In a strain gauge, do you need external energy? So all the transducer which don't need external energy are called active transducers, and other transducer which need energy, it is called the passive transducers. Very basic, very pet questions asked in an interview. Got it? Very good. Strain gauge, piezoelectric sensor. Read it loudly.
element used here is a pieces of crystalline material that produce an electric charge on its surface when it mechanically
Stop. It is active or passive? It is active transducer or passive transducer? See, in a mechanical deformation, it is giving you electric charge. So, mechanical deformation giving no energy supplied, only deformation. It is active. Got it? Then other effects. You read loudly.
Other electric effects commonly used in transducer are capacitive and inductive. In this case, the pressure produces a change in the capacitance or inductance of an electronics components in the transducer. Both these effects are commonly used in electronic oscillators, and one way they may be used to is to change the frequency of the oscillation. The frequency may be converted into a voltage representing the pressure.
This is a part of signal conditioning. But the other types may be capacitive or inductive. Now you see the capacitive transducer, how it works. You studied orifice, the P1, P2. That is an easier example for you to understand a differential pressure. So in that kind of transmitter, we have a like this, Okay, here it is coming P1, it is coming the P2. I will make like this, that you understand better. Like this. This is a P1, this is a P2. P1 and P2. What is happening internally? It is applied here and it is applied here. For your understanding. So what will happen? P1 is a this side of orifice, na? It is more, it is less. So we can write like this: delta P is equal to P1 minus P2, and it is varying because flow is have some It's a instantaneous flow, na? So what is happening? It is pressing. This diaphragm, it is pressing this side, this is pressing this side. It will be more pressed, it is less pressed. And then like this. So in a capacitor, if the distance between the two plates you can change, then voltage will change. So that change of voltage is equal to your delta P. In a inductor type, so what we have? We have a one coil, we have a coil. When there is a movement of this due to pressure, now P is applied here, it will move. This is LVDT. So it will produce a voltage, and that will be proportional to your pressure by using the proper signal conditioning. Got it? Piezoelectric got it? Strain gauge got it? Capacitive got it? LVDT inductive type got it? Very good. So this is today's topic is a pressure. So pressure, what we given you the important questions. Question number one is what is pressure? Definition of the pressure. Number two question we are giving you, what are the unit of pressure? Then third thing we have given the practical examples of pressure. It may be a knife, it may be a nail, it may be a tractor tire, it may be your bag strap, it may be your kitchen cooker. And then cooker, you also go to the process of the steam and the knowledge of boiling point. Why food cook faster in a cooker rather than an open pan? After that, we went to the four type of pressures. What are they? Absolute, gauge, ATM, and vacuum pressure. And then we also know the differential pressure. Then we seen the pressure gauge. This is the mechanical. Sensing is mechanical and it displays mechanical. Both are mechanical. So here what we are learning? We are learning sensor. We are learning transducer. We are learning display and controller also. So in this case, this is a pure mechanical. In this case, this is a diaphragm, some signal conditioning, and it is giving you output. Now you see, with this transmitter, what other interview question can come? First is, it is active or passive? Why? We are giving 24 volt to it. Second question, it is a 2-wire or 4-wire? 2-wire. Why? Because in these 2-wire, we are giving 24 volt and we are taking 420 milliamps. So today you will do the practical example also, how you will connect it. You will open it, see the connection also. Then inside this sensing element means sensor, we studied there may be many types. What types? Capsule, bellows, diaphragms, right? Now we see this signal conditioning and all the electrical may be different types. Some active, some passive. Capacitive type, inductive type, they all are passive. But you talk about piezo, that is active. So in the interview question, you learn that also, active and passive. What else you learn? Can you tell me?
Dynamic pressure.
You learn the static and dynamic pressure. And you learn very important thing is the head. The mechanical guys, when you work on the pumps, electrical guys, when you come work on the motors, or any engineering guys who is an auditor, energy or energy manager, we have to find out the efficiency of these machines. That time these formulas are very important. And you understand 1 kg per centimeter is equal to 10 meters head. Good. You also learned a instrument can give what kind of the outputs. So I told you it gives two. One is the electrical, other is the analog, other is the digital. In the analog, 4 to 20 milliamps or 0 to 5 or 0 to 10 volt. Means current or volt is the analog. In a digital, Modbus, Ethernet, Profibus, HART, BACnet, and there are many more proprietary also. So I think we have learned at least 20-25 questions of the interview. So in this second series, we will stopping here, and in the third series, we will take the temperature. And after that, we will take level. After level, what we are going to take? Vibration. Because again, when you know vibration basics, you will know many electrical mechanical basics. And after that, we will take you to that environmental instruments. Because right now it's a too boom. Like you cannot pollute water out from the factory or any gas or any flue gas outside the factory. So that we will see in a different 2 or 3 series. Thank you very much for watching.